look at the converses of the theorems that we did yesterday. And basically what it's doing is working things backwards. Yesterday we started with the idea that the lines are parallel. What can we conclude about the angle pair measurements? Today we're going to work it all backwards. We're going to say, okay, what do we need to know about the angle pair measurement to conclude that the lines will be parallel? So yesterday we started with parallel lines and made conclusions about angles. Today we're going to conclude parallel lines, and we're going to use the angles to make that conclusion. Now, from a practical purpose, we're really doing almost exactly the same thing we did yesterday, setting up and solving equations exactly the same way. It's just that the question is phrased differently, and the process is going to be essentially the same, despite the differently phrased question. So we start with our corresponding angles converse. And it says this, that if corresponding angles are congruent, if two lines are crossed by a transversal and the corresponding angles are congruent, then the lines must be parallel. So in this case, if angle 2 and angle 6 are congruent angles, then J must be parallel to K. Okay, makes sense. It's not a difficult idea. That pretty much makes sense. So we get to questions like this. What value of X makes M parallel to N? Now notice what we're doing is we're phrasing the question differently from yesterday. Yesterday we said M is parallel to N, find the value of X. Okay, today we're saying what value of X makes M parallel to N. Mechanically, from how we set up and solve the equations, nothing has changed from yesterday. Those are still corresponding angles. We have to identify the angle pair. In fact, when I identify the angle pair, according to my letter theory here, that's an F. It's an upside down flipped over F, but it's an F, corresponding angles. Corresponding angles need to be congruent for the lines to be parallel. So 3x plus 5 must equal 65. So 3x has to equal 60. So x is 20. Very straightforward. Do be careful. It is not at all uncommon for people to get a very simple equation like we had to start with here and do 3x equals 70 because they do plus 5 and they don't do all the steps properly in their head. That's why we want to show our work. Make sure you're always solving your equations accurately. Is there enough information in this picture to prove that M is parallel to N? Explain. Well, we do not have corresponding angles here. We do not know that the lines are parallel. We need corresponding angles to be congruent to show that. This is not a named angle pair, 75 and 105. Those are same side exterior angles. We don't have a theorem about that. But what can I do? I can still use the fact that I have linear pairs. I have a linear pair of angles here. I have a linear pair of angles here. Linear pairs, we know, are supplementary. So I know that this angle is 75, that this has to be 105. Or I could have done this 105 and said this is 75 right here. Either way. But once we've done that, oh, well then yes, the lines must be parallel because now the corresponding angles are congruent. So yes, by using linear pairs, we get congruent corresponding angles. So sometimes we have to do a little bit of extra work to make the conclusion. Based on just the facts we were given to start with, just the 75 and 105 in their original positions, was that enough to prove the lines are parallel? No. But with just a little bit of additional detective work, we're able to get to that conclusion. This is a big shock. We have converses for all of our theorems. The alternate interior converse, the alternate exterior converse, and the consecutive interior converse. Still the same thing. The alternate interior is if that's the case, and by the way, what letter do we see with the alternate interiors? This is kind of a funky one, but we can see it. It's a Z. What do we see with the consecutive interiors? We see the C. But if the alternate interiors are congruent, the lines are parallel. If the alternate exteriors are congruent, the lines are parallel. If the consecutive interiors are congruent or supplementary, the lines are parallel. Get carried away with congruence sometimes. The important thing is when we're dealing with a converse theorem, the converses show parallel lines. The regular theorems do not. The regular theorems show congruence or supplementary. The converses show parallel lines. Now, let's prove one of these. You weren't going to get away from proof too long. You knew that. We're going to be doing proof all year. Prove that if two lines are cut by a transversal, the alternate interior angles are congruent, then the lines are parallel. And so that the alternate interior angles are congruent, the lines are parallel. So they want us to write a proof. Now, this is a little bit tricky because the givens are kind of in the picture, but we got to work on that. But let's say our givens are, okay, G and H, line G. Lines G and H are crossed by a transversal. Okay, and angle 4 is congruent to angle 5. Prove G is parallel to H without using the alternate interior converse, because obviously that's a theorem that we're trying to prove. We can't use a theorem to prove itself. That doesn't make sense. So what are we given? First given, lines G and H. Crossed by a transversal. That's given. And we're given angle 4 is congruent to angle 5. Well, what can I conclude? Well, the picture has got an angle 1 set in there, so we're probably going to want to use that. That's a pretty good hint. What's the relationship between angle 1 and angle 4? They're vertical angles. So angle 4 is congruent to angle 1 because vertical angles are congruent. Now 4 is congruent to 5, 4 is congruent to 1, so therefore 1 is congruent to 5. Substitution, sorry, 4 substitution. And if 1 is congruent to 5, 1 and 5 are corresponding angles, so G, line G, is parallel to line H because of the corresponding, supposed to be 2 R's there, angles converse. So that's just a quick proof of that. Now again, you aren't going to be asked to do that on your own in the test or on a quiz, but it's just nice to see the way that works, and the more we can do examples proofs, the better you will become at them. R is parallel to S and angle 1 is congruent to angle 3. Prove P is parallel to Q. Okay, we aren't going to go through the whole written proof here, but let's just reason our way through it. It says angle 1 is congruent to angle 3. So we know that. And we know these two lines are congruent. Are parallel. Okay, well if that's the fact, then angle 1 must be congruent to angle 2 because they're corresponding angles. And angle 2 and angle 3 are now congruent because of substitution. If 1 is congruent to 3 and 2 is congruent to 3, then 1 is 3 and 1 is 2, then 2 must be congruent to 3. 3 and 2 are alternate interior angles, which means that if they are congruent, then these lines must be parallel. So again, there's a lot of stuff going on here. There's a final way to prove lines are parallel, and that's called the transitive property of parallel lines. It says if P is parallel to Q and Q is parallel to R, then P is parallel to R. Two lines parallel to the same line are parallel to each other. Again, a fairly obvious conclusion. Explain why the top stripe is parallel to the bottom stripe. If each stripe is parallel to one below it, that's simply using the transitive property or that last theorem. Obviously, all the lines are parallel, so they're all parallel to each other. Kind of a simple example. And finally today, I just want you to take a quick moment in your book, or in your notebook, or wherever you're writing, to list the different ways we can prove that lines are parallel. How can I prove that lines are parallel? Well, I can prove that lines are parallel by, if they're corresponding angles converse. We have the alternate interior. Okay. In fact, I'm gonna just do the relationship rather than the name of the theorem. Corresponding angles are congruent. If the corresponding angles are congruent, the lines are parallel. If the alternate interior angles are congruent, if the alternate exterior angles are congruent, the lines must be parallel. If corresponding, C words, consecutive interior angles are supplementary, then the lines are parallel. Or if both lines are parallel to a third line, to the same third line. Those are all different ways that we can prove that two lines are parallel. Is there another way we can prove lines are parallel? Yeah, there's going to be when we start the second part of this chapter after our quiz. We start looking at lines in the coordinate plane. How in the coordinate plane do I know if lines are parallel? Think about that from algebra. I'm just going to kind of leave you with that today. But in algebra, you don't need to know this for this quiz, but we'll get to this in the second half of the chapter. In algebra, how did we know what measurement told me that lines were parallel in the coordinate plane? So I just want you to think about that. We'll look at that later on. All right, well, we'll see you in class.